What's up, everybody? This is Danny Mathematics here with another example to explore. And today, guys, I want to go over example 1 and example 2 of how to solve problems that are dealing with compound interest, right? Now, what is interest? Interest, for example, let's just say, guys, that I have $1,000 and I opened up a high interest savings account, right? A high yielding savings account. So I put the $1,000 into the savings account, and let's just say that if it was based on simple interest, right? Let's just say that the interest rate is 4%. 4% of $1,000 is $40, right? So simple interest can only be applied to a principal, which is the start amounts, only once per year, one time per year, which is annually, right? So that extra $40 that I've earned will only be applied to my account once per year, right? Every year, one time annually. So every year my account, just from the principal, will grow an extra $40 each year because $40 is 4% of 1,000, right? Now the difference between simple interest and compound interest, remember I said simple interest can only be applied to the principal only once per year, right? Only annually, right? Compound interest can be applied to a principal multiple times per year, right? So for example, let's just say this guy, same situation. I have $1,000 I put into a savings account and the bank want to give me back 4% interest, right? For using their product, right? Or their savings account. 4% of 1,000 is $40, right? So now let's just say, guys, that I am compounded quarterly, right? Every season, and there are 4 seasons in a year, right? So instead of only the interest only being applied to the account one time within a year, because I'm being compounded quarterly, it's going to be applied 4 times in a year. If I was being compounded monthly, right? There are 12 months in a year, so the interest on my account will be compounded or complied to the balance 12 times in a year, right? So that's the difference between simple interest and compound interest. Simple interest can only be applied annually. That means one time or once per year. Compound interest can be applied multiple times per year depending on how it's being compounded, okay? So let's just go over the formula of compound interest. All right, I have A equals P, which is the principal or the start amount or the initial balance, right? However you want to say it, times parentheses 1 plus R, which is the interest rate, divided by N, which is the number of times the interest rate is compounded in a year or per time period, which is a year, right? Divided by N, parentheses close, to the power of N, which is the number of times the interest rate is compounded, times the T, which is the number of years, time, which is number of years, right? So once again, guys, this is our formula. A equals P times parentheses 1 plus R over N, parentheses close, to the N times T power, okay? That is the formula that we're going to use. And once again, guys, these are the different parts within the formula, right? Once again, A is the final amount, P is the principal or the initial balance or start balance, R represents the interest rate that's being provided, N is the number of times the interest rate is being compounded per year or per time period, and T is, of course, the number of years, right? Now, let's just get to the different ways that an investment can be compounded, right? Or debt can be compounded, right? Let's just say that it was compounded half yearly. That means twice per year, right? That means that every half of year, right, is going to get compounded, right? So that's twice per year. Let's just say that it's compounded quarterly, right? There are 4 seasons in a year, right? So it will be compounded 4 times, right? One time in the spring, one time in the summer, one time in the fall, one time in the winter, right? Monthly is 12 times because there are 12 months in a year. So every month, the interest will be applied if it's compounded monthly. And weekly, it will be 52 times because there are 52 weeks in a year. So it will be compounded 52 times within a year span, okay? So these are just some notables. There are other ways to be compounded, but these are the main 4, all right? So today, guys, remember, I want to touch on example 1 and example 2. Now, as I read example 1, guys, example 2 is going to be the same as example 1, the same information. The only thing that's going to be different, guys, is how it's compounded. How it's compounded. And the reason why I did it this way because I want to use the same numbers, but show you that if it's compounded differently, then the results will be different, even though we're dealing with the same numbers, same interest, same principle, okay? So it's the way it's compounded, all right? So everything is read the same, guys. The only difference is it's gonna say compounded monthly here and quarterly here. So I'm just gonna read the top, but I'm also reading the bottom as well, okay? So once again, it's saying the same thing other than the way it's compounded. It says if you have invested $2,000 into a bank account at an annual interest rate of 5% compounded monthly, right? Then how much would you have in the account after 2 years, right? Same thing. It's saying the same thing here, guys. If you invested $2,000 into a bank at an annual interest rate of 5% compounded quarterly. So here is monthly, here is quarterly, right? Then how much money would you have in the account after 2 years, right? So once again, guys, all the information is going to be the same. The only difference is going to be in, which is how it's compounded. Because up here, it's going to be compounded monthly, which is 12 times in a year, but here is going to be compounded quarterly, which is only 4 times a year, okay? So I just want to just show that, guys. I just want to show that, all right? So let's just go ahead and put this information in. Everything else is the same. All right, because literally I use the same information. I just change how it's compounded, okay? All right, so once again, guys, in both situations, guys, the principal or the start balance was $2,000. So I'm going to put 2,000 as P, $2,000, okay? And $2,000. Let me get another blue marker real quick. Thank you. And then $2,000. So it's much better marker. $2,000, all right? So $2,000, $2,000, that's the same, all right? In both situations, the interest rate was 5%. The interest rate was 5%. So R, which is the interest rate, I'm going to put 5%. All right, and then also, guys, remember we have to always change the percent to a decimal when we're dealing with interest rates, right? Compound interest and simple interest, same thing. So we have to change 5% to a decimal of 0.05. Just like that, okay? Same thing down here, 5%. Which equals 0.05. Okay, just like that, all right? The number of years, T, it says 2 years. All right, so they have, in both situations, it's 2 years. That's the time span we're checking, all right? But the only difference is how it's compounded. Here, guys, the investment is gonna be compounded monthly. That means 12 times per year. That means 12 times per year, right? That means 12 times. So I'm just gonna put 12x. It's just saying 12 times per year that is gonna be compounded, right? That's why I put the X afterward, right? Same thing over here, guys. It says quarterly. Once again, there are 4 seasons in a year, right? Every quarter is a season, right? So that's 4 times. So this investment is gonna get compounded 4 times within a year, okay? While this one, since it's monthly, is gonna be compounded 12 times within a year, right? So now, guys, all we have to do is just plug this information, all of these values, where they go within the formula, okay? So I'm just gonna follow the formula right there. In both situations, I'm gonna follow the formula in both situations. Okay, so I have A equals. All right, we're gonna start off with P. Once again, in both situations, P is the principal, which is $2,000. So I have the final amount equals 2,000. All right, times parentheses 1 plus all right, and it's going to be R over N, which is the number of times it's compounded. R is the interest rate, but we have to have it as a decimal. So it will be 0.05, 1 plus 0.05 divided by, right? Divided by n. N is the number of times it's compounded within a year, right? In the first situation, it's compounded 12 times, right? Because it's monthly. So I'm going to put 12. Okay? And this second example is compounded quarterly, which is 4 times a year. I'm going to put 4 as n. Okay? And then last but not least, guys, we have to put the exponents. Once again, n is the number of times it's compounded times t, which is the number of years, right? So in this situation right here, guys, it's compounded 12 times, right? Times how many years? 2 years, right? Because they want to know what is the final amount after 2 years. Just like that, okay? So the exponent is 12 times 2, which will be 24. I'm going to write it in eventually. Same thing down here, guys. But it will be different. N will be 4, because it's compounded quarterly, times the span of 2 years. Okay? Same thing. Times the span of 2 years. Let me just make it look exactly alike. I want to use all the same colors. Okay? Cool. All right? So now, ladies and gentlemen, all we have to do is just take a calculator. First, we have to simplify just a little bit, and then after we simplify the expression, we take a calculator, and then we just solve, okay? So let me just simplify some parts, guys, okay? In both parts, guys, I would simplify the exponent, right? The exponent is 12 times 2 is 24. So that would actually be 24. Right here, 4 times 2 is 8. So that actually be to the exponent of 8. Okay? Now, the only other part that we have to simplify, guys, is the interest rate divided by the number of times it's compounded, right? So let's do the first one, guys. We have 0.05 divided by 12. 0.05 divided by 12. Okay. That is going to equal, all right, 0.00416. 0.00416. It's a repeating decimal, but whatever. I'm just going to leave it like that. Okay. So this part right here equals this. Okay. I'm going to do the same thing right here, guys. I'm going to do the same thing right there. I have 0.05 divided by 4, which is 0.0125. Okay, so let me put that 0.0125. Just like that. Okay, now the last part, guys, that I need to simplify is what's in the parentheses, right? What's in the parentheses, right? Which I actually should have did that first because PEMDAS parentheses come before exponents, but it doesn't matter. We good, all right? So 1 plus 0.00416 equals 1.00416. So that is the value that's going to be inside the parentheses now, right? And then we're going to still, in this first case, still multiply that by 2,000 after we hit it with the exponent of 24. Okay? All right, so we can actually solve the first one, guys. We can actually solve the first one right now. Let me go ahead and put that number inside. I'm going to do parentheses. I'm just going to write it the way it is. So I have 2,000 times, I'm going to put it in parentheses, 1.001416, parentheses 2 the 24th power, parentheses close. Okay? And that will equal, guys, $2,209.54. Okay? So this is the final amount that the account has, right? After 2 years. $2,209, right? And 53 cents. Okay? That is the final amount in the account. Okay? All right, now I'm gonna do the same thing down here, guys. I'm gonna do the same thing down here. Once again, 1 plus 0.0125 equals 1.0125. Okay? And once again, guys, everything else is the same. This is gonna be to the 8th power in this particular case, and it's gonna be multiplied by 2,000. Okay? And then now we're gonna get our final answer. So same thing, guys. I'm gonna do the same thing. I'm gonna have 2,000 times parentheses, and then put it again in the parentheses, 1.0125, parentheses to the 8th power, and then with another parentheses. Give me 1 second, let me fix this. Okay, boom, boom, boom. Okay, so then the answer to this one, guys, will be $2,208.97 right? Somewhere around there, guys. That will be the final amount after 2 years, okay? Now, the reason why I wanted to show these two examples that were very similar but yet different is because I wanted to show you the difference in the amounts, right? If you notice, guys, when it was compounded monthly, which is 12 times per year, right? The final amount is a little bit higher than the final amount if it was compounded quarterly, okay? It's just a little bit higher. Of course, with bigger numbers, you will see more of the contrast in the amounts. Even though the amounts are very, very close, this amount is a little bit higher because with the same amount and the same interest, if it's compounded more often than not, right, or compared to another situation, then that amount will be higher, okay? So because this situation was compounded 12 times in a year versus this only being compounded 4 times in a year, this was gonna draw more interest because more interest is hitting the account more often than this particular situation, okay? So once again, guys, these are just two examples that had the same principle, the same interest rate, the same number of years, but how it was compounded was different, right? This was compounded monthly, so it had a different amount, a final amount. This was compounded quarterly, right? We just had a different amount, right? So the amounts were close, but yet they are different, okay? So thank y'all so much, guys, for tuning in. My next video, I'm gonna do the same thing with example 3 and example 4. Thank you.